Every time a user checks a bank balance, orders a ride, or refreshes a feed, they are making an API call. But before any of those thousands of requests can execute backend code, they all have to funnel through a single entry point. That point is your API gateway. It acts as the reception desk for your architecture. It verifies who is knocking, checks how many requests they've already made, and routes them to the correct internal service. Operating without one leaves your backend completely exposed to the open internet. You are forcing your individual microservices to absorb brute force logins and distributed denial of service attacks directly. Look at the difference here. An unprotected architecture forces every service to defend itself simultaneously. A gateway-protected setup filters the noise at the edge, meaning your internal services only process clean, validated requests. Keep in mind, a gateway does not relieve your backend of its security duties. It adds a specialized perimeter layer to enforce policies, but your core application still has to authorize the final actions. You know you need a gateway. The problem is choosing one. You have 6 dominant industry-standard tools in front of you, and picking the wrong one is an expensive, permanent mistake. The decision comes down to a strict trade-off. How much operational control do you demand versus how much infrastructure overhead are you willing to tolerate? Get this balance wrong, and you will either bleed money overpaying a cloud provider for massive traffic volumes, or you will drown a small engineering team in the maintenance of open-source servers. We aren't going to evaluate these tools by reading down a generic feature list. We are going to match them to your specific cloud environment and your team's operational maturity. An API gateway is an architectural commitment that dictates how your engineering team will deploy, secure, and monitor traffic for years. This quadrant chart maps our options. Managed gateways offer zero infrastructure maintenance. AWS API Gateway dominates here, but at $350 per million requests, costs can skyrocket. Azure API Management sits higher on the lifecycle axis, offering built-in developer portals. But Azure APIM relies on a heavy policy processing engine, resulting in lower raw throughput and higher latency than leaner competitors. For developers using open API specifications, Google Cloud Endpoints offers a lightweight, minimal configuration alternative native to GCP. Choosing a managed gateway buys engineering velocity today, but you trade away architectural flexibility across different cloud providers tomorrow. To avoid vendor lock-in and control scaling costs, you have to move to the open source options, but that freedom means taking on the burden of hosting the infrastructure yourself. This bar chart compares raw throughput. NGINX stands alone, processing over 50,000 requests per second, with a microscopic 1 to 2 milliseconds of latency. For sheer performance, this is it. Back on our quadrant map, NGINX lands in basic routing, demanding deep configuration expertise. Meanwhile, Kong sits higher up, powered by a massive plugin ecosystem, the standard for multi-cloud Kubernetes. Kong's drawback is operational weight. Without the enterprise tier, your team is fully responsible for managing the gateway nodes and the underlying database architecture. Rounding out the open source list is Tyke. It emphasizes developer experience, providing an out-of-the-box portal and detailed analytics without a managed cloud provider. Open source gateways offer ultimate scale and freedom, but they only make sense if you have a dedicated platform team keeping the engines running. At this point, teams often introduce a confusing variable, deciding whether to skip the gateway entirely and deploy a service mesh. This Venn diagram clears it up. A service mesh strictly controls internal traffic between microservices. They share an overlap in observability, but their core jobs are distinct. Deploying a service mesh at your external perimeter is an architectural error. A mesh is completely unsuited for handling client rate limiting or OAuth from outside users. The rule of thumb is simple. Start with an API gateway. Only introduce a service mesh when you exceed 10 internal services and manual communication becomes unmanageable. A service mesh over-engineers the front door, while a gateway alone cannot securely route complex internal traffic. You apply them to different problems. Let's lock in your choice. We can map your exact constraints to the right tool, based on your cloud strategy, your team maturity, and your traffic volume. Here's the decision flowchart. Invested in AWS or Azure? Use their native gateways. Running multi-cloud on Kubernetes? Choose Kong. Need extreme performance at the edge? Route to NGINX. Packaging APIs for external developers? Tyke and Azure APIM provide day-one monetization portals. The superior tool is never the one with the longest feature list. It is the exact tool that matches your team's operational reality. Buying the correct gateway solves your vendor problem, but if the software is configured poorly, your perimeter is still wide open. The most common fatal flaw is applying a generous global rate limit, but failing to lock down your authentication endpoints. Attackers relentlessly hammer your login route. You need aggressive limits, 5 requests per minute, applied specifically to auth endpoints. Another massive vulnerability comes from lazy development setups making it to production. Leaving wildcard cross-origin resource sharing active allows any domain to request data from your backend. Finally, do not let your gateway terminate SSL for the external client, only to send that traffic unencrypted through your internal network to the backend. Fix these operationally. Enforce strict auth rate limits, whitelist specific CORS origins, and utilize internal CA certificates to maintain encryption straight to the application code. Mastering gateway configuration secures the perimeter. Next, we must tackle how you verify the identity of the users walking through the front door. We'll cover that in our deep dive on authentication.